Hello, welcome to lesson 2.1. This is about lines and slopes. Next lesson is quadratics, and then the lesson after that I think is exponentials. So we're just kind of running through the different types of functions, and that's what topic 2 is. So functions and all the fun stuff you get to do with those. So topic 2, starting with lines. Gradient. Slope, gradient, same thing, it's just gradient is British for slope. In the coordinate plane, the ratio of the change along the y-axis, better known as the rise, to the change along the x-axis, the run. It's the rise to the run. Alright, so in general, if you've got 2 points, x1, y1, x2, y2, for coordinates a and b, your slope is the change in the y's, so y minus y, over the change in the x's, x minus x. Y is your vertical. Okay, so that's why we call it rise, because you're moving up and down on the y-axis. And the run is your left and right. That's, I don't know why we call it run, it's alliteration. Another way of saying that is a rate of change. So anything that changes is slope. Like velocity is your change in position. Velocity is the slope of position. Acceleration is your change in velocity. Acceleration is the slope of velocity. Alright, so moving on to some examples. Find the slope of the line that goes through this point. So imagine you had the point 3, -4. What's the slope that goes through that point? Well, you could have any number of lines. There's an infinite number of lines that goes through that point. So this one, you need another point. In geometry, we learned that you need at least 2 points to make a line. So you need 2 points to have a slope. Find the slope of the line that goes through these 2 points. So very quickly, you just do y minus y. So it doesn't matter which one is y1. So 1 minus -4, this should not be anything new, over -6 minus 3. So there's your rise over your run. So 5 over -9. That would be your slope. Find the slope of the line that goes through these 2 points. Okay, so your rise is your 3 minus 3, and your run is -3 minus 4, which is 0 over -7, which is 0. So what kind of slope has what kind of line has a slope of 0? So if it has a 0 slope, that literally means no slope. Think of if we were to go sledding on a hill with no slope to it, what kind of hill would that be? It would be a horizontal line. Horizontal line has no slope. And the equation for such a line is just y equals whatever the y equals. So in this case, y was 3 at this point. And at this point, y was 3. So any point on this horizontal line is going to have a 3 for your y value. So the equation is just y equals 3. What about this one? Find the slope of the line that goes through these points. So now let's do rise. So 2 minus -3 over run, 4 minus 4. In this scenario, you've got 5 over 0, which is undefined. What kind of slope has an undefined slope? What kind of line is an undefined slope? 0 is horizontal, undefined is vertical. And notice that in this coordinate, the x value is 4. In this coordinate, the x value is 4. Any point on this vertical line will have x equals 4. That's how you make that equation. So this is the equation for the line that goes through those points. This is the equation for the line that goes through those points. So it's something you have to know. Horizontal is y equals, vertical line is x equals. Should be easy. Easy lines to do. Alright, look out for these 4 questions. We've got 2 points of the same P and Q for all of these. Find the midpoint slope, find the length, and there's another question. So first one is find the midpoint. So literally all you're doing is averaging the x's. So what's the average of 1 and 4? 1 plus 4 divided by 2. And what is the average of 2 and 6? 2 plus 6 divided by 2 is that. So there's your midpoint. It's right in the middle. It's in the middle of 1 and 4, and it's in the middle of 2 and 6. Midpoint. Next, find the slope. Easily done. We usually call that m for slope. I don't know why they call that m, but that's what they do. So it's rise over run, so 2 minus 6, 2 minus 6 over 1 minus 4. Call that 4/3. Here's our slope. We're on a graph. You go up 4 over 3, up 4 over 3 like that. Next says find the, there's nothing here. It's not segment PQ, it's not line PQ, it's length of PQ. That means length, which requires the distance formula. So for the distance formula, this is technically prior knowledge. In fact, a lot of this lesson is prior knowledge. You'd see this on the prior knowledge part of your formula packet. It's x minus x, y minus y. Notice that the x's are treated together and the y's are treated together. Just like in the slope, the x's are treated together and the y's are treated together. You always separate x's and y's when you're working with them. Okay, so now we're going to plug this into the distance formula. So 1 minus 4 squared and 2 minus 6 squared. So 1 minus 4 is negative 3. Negative 3 squared is 9. 2 minus 6 is negative 4. Negative 4 squared is 16. That's the square root of 25, which worked out nicely to be a 5. So the distance from this point to this point on the coordinate plane is 5 units. And then lastly, we have PQ, and now we're going to bring in R. So here's the situation. You've got P, you've got Q, you've got R. Q is the midpoint of segment PR. P is 1, 2. Q is 4, 6. And R is unknown. We got to figure out what R is. So Q, let's look at the x's. 4 minus 3 is 1. So to get to this coordinate, you have to add 3. So subtract 3 to get to 1, add 3 to get to 7. I'm just going to write it out here because I'm out of room. 6. 6 minus 4 is 2. So 6 plus 4 is 10. And therefore that makes it right in the middle. It's the 4 is right in the middle of 1 and 7. 6 is right in the middle of 2 and 10. Makes it right in the middle. Next, let's talk about parallel and perpendicular. Slopes of parallel lines, two non-vertical lines, have the same slope if and only if they are parallel. So if you remember back to geometry, if and only if means P implies Q and Q implies P. They work both ways, so same slope implies parallel and parallel implies same slope. That's the if and only if there. And then you have to state that all vertical lines are parallel because the slopes are undefined for vertical. So that's kind of like something that you have to state just on the side there. All vertical lines are parallel. And then also all horizontal lines are parallel. So this is an assumption we're going to make moving forward. Are all vertical lines parallel? Let's think about that. So all vertical lines never intersect, is what this is saying. Alright, let's go to different points on the globe. And we're both going to walk south. We are walking parallel to each other. You're walking south and I'm walking south. In that scenario, do those vertical lines are they parallel? No, because eventually we're going to hit the South Pole. Alright, so this is true for a flat surface. It's not necessarily true for other types of surfaces. Next, perpendicular. Slopes of perpendicular lines are perpendicular if and only if, there's that if and only if again, the product of their slopes is -1. You probably remember this from algebra class as opposite reciprocals. Probably didn't spell it right, but you get it. So for example, a slope of 3/4 and a slope of -4/3 would be opposite reciprocals. They're opposite, this one's positive, this one's negative, and they are reciprocals. This is 3/4, this is 4/3. And if you multiply those together, you get -1. So if their slopes is -1, then they're perpendicular. Another name for perpendicular in British terms is normal line. So perpendicular line means normal line. Same idea. So example 9 already. Wow. Determine whether these lines are parallel, perpendicular, or neither. So let's find the slope here. The slope of this is 1 minus -5. I'm doing rise over run. So y minus y. 1 minus -5 is 6. 1 minus -1 is 2, which makes that slope 3. For CD, we've got the slope of 2 minus 1 over 3 minus 6. So how do these two slopes compare? What is 3 times -1/3? -1. They are perpendicular. There's one way to say that. So these lines are perpendicular. Example 10. Graph a line that is perpendicular to and goes through the midpoint of segment AB if A is -3, 3. So -3, 3. Here's A. And B is 1, 7. Here's B. Okay, so those are my 2 points. Graph the line that is perpendicular to and goes through the midpoint. So first we got to find the midpoint. And you can do this graphically. It's pretty easy in this scenario because you can see a pattern, up 2 over 2, up 2 over 2. This has to be right in the middle. You can make it a midpoint by putting those marks. Or you could do it analytically. What's in the middle of -3 and 1? -3 plus 1 divided by 2. -3 plus 1 divided by 2 is -1. 3 plus 7 divided by 2 is 5. -1, 5. There it is. So there's your midpoint. And it has to be perpendicular. So we're making a line that has to be perpendicular to this. So the slope of this line is up 1 over 1. So therefore the slope of the perpendicular line, that's a symbol for perpendicular if you don't remember, is -1. Opposite direction. So here it is. We're just going to start here and go. For all these examples, you need to pause the video and do it yourself first, and then you can watch me do it. So there it is. There's the line we were looking for. Next, let's talk about equations of lines. Probably remember these. We have 2 forms of a line, actually 3 forms. There's one called standard form, But we have slope-intercept form, we have point-slope form. So in British terms, they'll call this gradient-intercept form. So that's what that means. Slope-intercept, M is the slope, and B is the y-intercept. So example, find the equation of the line that goes through these 2 points. So we can start with y equals mx plus b and plug in as we go. Do we know the slope? Sure, let's find the slope. The slope is 5 minus 3, which is 2, over 0 minus 4. So negative 1/2. Either way you go, you're getting negative 1/2. So our equation now turns into negative 1/2 x plus b. Now also we have a point. We have, for example, 4, 3. We also have 0, 5, but let's use 4, 3 just because I want to show you. That's an x and a y. And now what we can do is we can plug in the x and the y. So our equation turns into 3 equals a negative 1/2 times x plus b, which means 3 equals negative 2 plus b, and you get that 5 equals b. So therefore our line is turned into y equals negative 1/2 x plus 5. Now there was a shortcut to find that 5, wasn't there? Yes, because this equation had 0, 5. Whenever it has 0, your y-intercept is whatever that is. So, but anyway, there's our line. And if we were to graph this, we would go up to our graph, for example. We'd start at 5, and then we'd go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, and vice versa. And this would be our line. Now let's check. Does that line go through 4, 3? Sure does. Does that line go through 0, 5? Sure does. So that is the line we're looking for. The next form of line is called point-slope form. This is my favorite because as long as you have a point and a slope, you're good to go plug it in. The point xa, ya is just any point. Alright, so you still have your slope, and this is any point. So find the equation of the line that has a slope of 3 and goes through 2, 5. Slope of 3, so the slope, I like to even write it out when I'm doing these. I'll literally write out slope equals 3, point equals 2, 5, and so we can just plug that in. Y minus the y value of my point equals slope times x minus the x value of my point. Now from there, you can leave it like that, or you can make it look like this form. So that would be y minus 5 equals 3x minus 10. And lastly, y equals 3x. Add the 5 over, minus 5. So there it is. And if we were to graph this, we would go up to here, for example. We'd start at negative 5. We'd go up 3 over 1. So you gotta go up 3 over 1, 3 over 1, 3 over 1, and so forth. The line would look something like this. Does it go through the point 2, 5? Nope, sure doesn't. Goodbye, God. What did I do wrong? Adding 5, 2, 5. Oh, 3 times, oh, duh. 3 times 2 is not negative 10, it's 6. Duh. Now add 5, you're going to get 1. my line.